A very good morning, dear children. Today we are going to see the remaining part of the chapter number 5 inside the atom elements. We have seen that 2, 8, 18, 32 dash dash electrons can be accommodated in the shells K, L, M, N respectively. So this is the maximum capacity of that shells. So the electrons in an atom are distributed in the shells according to their maximum capacity. So the shell-wise distribution of the electron in an atom of an element is called as electronic configuration of that element. So each electron has a definite energy as per the shell in which it is present. So the energy of an electron in the first shell, that is K shell, is lowest. The energy of electron in the subsequent shells goes on increasing with the ordinal number of the shell. So the electronic configuration of an element is such that the energy of all the electrons together is the maximum possible. And therefore the electrons get a place in a shell in accordance with maximum capacity of the electron shell in that atom and in the increasing order of that energy. Filled in this table, and according to this we have to fill rest of the table. So atom is given hydrogen, symbol for this H, electron number in the atom, that is 1. So distribution of electrons, that is in K shell there is 1 electron. So in electronic configuration we can write only 1 electron. Now second element is, that is second atom is helium, symbol for that atom is He. Okay, then electron number in the atom, that is 2 electrons. Distribution of electrons in K shell, that is 2 electrons. So electronic configuration will also 2 only. Now next atom is lithium, symbol is Li, that is capital L and small I. Electron number in the atom, that is 3. Then distribution of electron in K shell there will be 2 electrons and in L shell there will be 1 electron. Now electronic configuration will be 2, 1. Now next atom is carbon. Symbol for that carbon is C. Now electron number in the atom, that is 6. So distribution of electron, that is in K shell there are 2 electrons and in L shell there will be 4 electrons. So electronic configuration will be 2, 4. Now next atom is nitrogen. Symbol will be capital N. So the electron number in the atom, that is 7. Okay. Then distribution of electrons in K shell there are 2 electrons and in L shell there are 5 electrons. So electronic configuration will be 2, 5. Now next atom is oxygen. Now symbol will be O. Now electron number in the atom, that is 8. Now distribution of electrons, that is in K shell there will be 2 electrons, in L shell there will be 6 electrons. So electronic configuration will be 2, 6. Now next atom is fluorine. Symbol will be capital F. Now electron number in the atom, that is 9. Now distribution of electrons, in K shell there are 2 electrons, in L shell there are 7 electrons. So electronic configuration will be 2, 7. Now next atom is neon. Symbol for that capital N, small e. So electron number in the atom, that is 10 electron. Now distribution of electrons will be 2 electrons in K shell and 8 electrons in the L shell. So electronic configuration will be 2, 8. Now next atom is sodium. Symbol for that sodium is capital N, small a. So electron number in the atom, that is 11. Now distribution of electrons, in K shell 2 electrons, in L shell there are 8 electrons and in M shell there are 1 electron. So electronic configuration will be 2, 8, 1. Now next atom is chlorine. So symbol will be capital C, small l. So electron number in the atom, that is 17. So therefore distribution of electrons will be 2, 8, 7, means in K shell 2 electrons, in L shell there are 8 electrons, then in M shell there will be 7 electrons. So electronic configuration will be 2, 8, 7. Now next atom is argon. Symbol for argon is capital A, small r. So electron number in the atom, that will be 18. So distribution of electrons: in K shell there are 2 electrons, in L shell there are 8 electrons, M shell contains 8 electrons. So electronic configuration will be 2, 8, 8. Now next atom is bromine. So the symbol will be capital B, small r. So electron number in the atom will be 35. Distribution of electrons: so K shell contains 2 electrons, L shell contains 8 electrons, M shell contains 18 electrons, and N shell contains 7 electrons. So electronic configuration will be 2, 8, 18, 7. So this will be the electronic configuration of some elements. Configuration in the numerical form contains numbers separated by commas. So here the numbers indicate the electron numbers in the shells with increasing order of energy. For example, the electronic configuration of sodium is 281. It means that the total 11 electrons in sodium are distributed as 2 in the shell K, 8 in the shell L, and 1 in the shell M. So the electronic configuration of an atom can also be represented by shell diagram as shown in the figure 5.8. Valency and electronic configuration. We have seen in the last chapter that valency means the number of chemical bonds formed by an atom. We also saw that generally the valency of an element remain constant in its compounds. Now let us see, children, use your brain power. What are the symbols used for the shells which accommodate the electrons in various atoms? So the symbols used for the shells which accommodate the electrons are K, L, M, N, dash dash respectively. What is the symbol and ordinal number of the innermost shell? So the symbol of the innermost shell is K and the ordinal number of this innermost shell is 1. Now third question, write symbol of electron distribution in shell of fluorine atom. So the symbol for fluorine atom is capital F and electronic configuration of fluorine will be 2, 7. Now which is the outermost shell of fluorine atom? So the outermost shell of fluorine atom is capital L. Which is the outermost shell of sodium atom? So the outermost shell of sodium atom is M shell. Now which is the outermost shell of hydrogen atom? So the outermost shell of hydrogen atom is K shell. Now these concepts regarding valency of an element in chemical bonds in compounds get clarified from the electronic configuration. Now atom forms chemical bonds by using electron of its outermost shell. So the valency of an element is determined by configuration of its outermost shell. So therefore the outermost shell is called as valence shell and the electrons in the outermost shell are called as valence electrons. Of an atom is related to the number of valence electrons in that atom. So let us first see add the element helium and neon. So atoms of both these gaseous elements do not combine with any other atom. So these elements are chemically inert. It means that their valency is 0. Valencies of hydrogen, chlorine, oxygen, sulfur, nitrogen, carbon, bromine, iodine and sodium. So molecular formulas are H2, then HCl that is hydrochloric acid, H2O that is water, H2S that is hydrogen sulfide, NH3 that is ammonia, CH3 that is methane, HBr hydrogen bromide, HI that is hydrogen iodide, and sodium hydride. So according to these molecular formulas, we have to find out their valency. So first molecular formula is H2. So in H, that is atomic number of hydrogen is 1. So there are only 1 electron. So obviously valency for hydrogen will be 1. Now next molecular formula is HCl, that is hydrochloric acid. So we have to calculate its valency. So there is simple method is there, children. You can see that method in this box also, that is H valency we have to write down, and then chlorine valency, then also you can get the answer. Or instead of that, you can write their number of hydrogens and number of chlorine atoms in that HCl. So here number of hydrogen in HCl that is 1, and number of chlorine atom in HCl that is 1, and then afterwards you have to cross multiply it. So whichever number corresponds to that H, that will be the valency of hydrogen, and whichever number corresponds to Cl, that is chlorine, that will be the valency of chlorine. So obviously hydrogen and chlorine here 1 atoms are there in hydrochloric acid. So due to that their valency will be 1 only. Now next is H2O. So in H2O, number of hydrogen atoms are 2 and oxygen are 1. Okay. So therefore, after cross multiplying, we will get the valency for hydrogen 1, and that for oxygen will be 2. Now next is H2S, that is hydrogen sulfide. So number of hydrogen in H2S, that is 2, and then number of sulfur atoms in this H2S only 1. So due to that, after cross multiplication, we will get the valency for hydrogen as 1, and for sulfur it will be 2. Now next is NH3. So in NH3, number of nitrogen that is 1, and number of hydrogen that is 3. So after cross multiplying, valency for nitrogen will be 3 and valency for hydrogen will be 1. Now next is CH4. So in CH4, number of carbon that is 1, number of hydrogen atoms that is 4, and after cross multiplying we will get number of carbon will be 1 and number of hydrogen that is given 4, and due to that after cross multiplying we will get the valency for carbon as 4 and number of hydrogen, that is valency for hydrogen will be 1 only. Now next is HBr, that is hydrogen bromide. So in hydrogen bromide, hydrogen and bromine atom 1 are there, and due to that both the valencies will be 1. Now in hydrogen iodide also same, that is number of hydrogen and iodine atom are 1, and due to that after cross multiplying also their valencies will be 1 only. Now next is sodium hydride, that is NaH. So number of sodium atoms and number of hydrogen atoms in NaH, that will be also 1, and due to that their valency will be 1 only. So these are the some valencies with the help of their molecular formulas. So these valencies I have shown here after the table also, children. You can see some valencies, and according to that you will understand how to calculate the valency or how to determine the valency of some element or atom according to their molecular formulas. Atom contains 2 electrons which are accommodated in the first shell, that is K shell. So you can see the table 5.7, then you will understand that, children, helium has only 1 K shell that contains electron, and the same is to also the outermost shell. So K shell is the outermost shell in helium atom because it contains only 1 shell. So the electron capacity for this K shell will be 2 electrons, because 2n square, according to that formula we can calculate. So we will get the capacity of K shell will be 2 electrons. So this indicates that the outermost shell of helium is completely filled. So it is said that helium has an electron duplet, And the electronic configuration of the inert gas neon contain two shell, that is K and L shell. L shell is the valence shell of neon. So the electron capacity of L shell will be 8, okay, according to the formula 2n square. Okay, so this table 5.7 also shows that the valence shell of neon is completely filled, and it is said to that neon has an electron octet because neon valence shell contains 8 electrons. Now argon is an inert gas having electron in the shells, that is K, L and M. So the electron capacity of M shell will be 2 into, that is 3 square. So it will be 18 electrons because 3 square is coming 9 and 9 twos are, it will be 18. So however in argon there are only 8 electrons in the valence shell, that is M shell. So it means that there are 8 electrons in the valence shell of inert gases, that is an electron octet. So from this it is understood that the valency is 0 when electron octet or duplet is complete. So the electronic configuration of the elements other than inert gases show that they do not have electron octet or their electron octet are incomplete. So regarding hydrogen, it can be said that its electron duplet is incomplete because hydrogen contains only one electron in the valence shell, that is in K shell. Now, atom of all elements except inert gases have tendency to combine with other atoms. Means they have a non-zero valency. So you have seen from the formula of the molecules from by combination with hydrogen, that is H2HCl, that valency of hydrogen is coming 1. So the electronic configuration of hydrogen shows that there is one electron less than the complete duplet state. And this number 1 matches with the valency of hydrogen, which is also 1. So we have learned that from this electronic configuration of sodium, that is 281, has one electron in the valence shell, and due to that the valency of sodium is also 1 from its molecular formula, that is NaCl NaH, that is sodium chloride and sodium hydride. So it means that there is some relation between the valency of an element and the number of electrons in its valence shell. Now use your brain power. So from the following table 5.9 shows that molecular formula of compounds formed by some elements. So write their valency of the respective element obtained from them and also their electronic configuration and the number of valence electrons in the empty space. So here symbol of element is H. Molecular formula will be HCl. So valency of the element will be 1. Now electronic configuration of the element is 1 and number of valence electrons, that will be 1. So if this number of valence electrons are greater than 4, then we have to subtract this from 8 minus x. Now symbol of element is Cl. So molecular formula of the compound will be HCl. Valency of the element is 1. Now electronic configuration of the element, that is 287. Number of valence electrons from this formula, that is 8 minus 7, that is we have to calculate, that will be 1 because number of valence electrons are 7. So according to the formula 8 minus 6 because that is greater than 4, okay, greater than or equal to 4, and due to that it will be 8 minus 7 is equal to 1. So according to that we can find out the valency for chlorine, that is 1 only. Now neon, symbol is Ne. So molecular formula, so no molecular formula because that is a inert gas. Now valency of the element, that will be 0 because electronic configuration is 2, 8. So number of valence electrons, that is 0. Okay, why valence is 0? Because 8 minus 8, that is also coming 0. And neon is a inert gas and there is a completion of octet. valence shell contains 8 electrons. It will not take any electron or it will not give any electron to other atom. Now next symbol is, that is fluorine F. So molecular formula is HF. Valency of the element is 1. Electronic configuration, so fluorine contains 9 electrons, or 9 is the atomic number, okay, and due to that electronic configuration will be 2, 7. Number of valence electrons, that is 7. So 8 minus 7, that will be 1. Now next symbol is sodium Na. Molecular formula NaH, sodium hydride. Valency of the element will be 1. Electronic configuration 281. Okay, so number of valence electrons are also 1. Now next is magnesium. So molecular formula will be MgCl2, that is magnesium chloride. Valency of the element, that is 2. Electronic configuration 282. Number of valence electrons are 2. So valency of magnesium obviously 2. Next symbol is carbon C. Molecular formula of the carbon, that is carbon molecule compound, that is CH4. So valency will be 4. Electronic configuration of the element, that is 2, 4, because atomic number of carbon is 6. So electronic configuration will be 2, 4. So number of valence electrons will be 4. Now symbol of element is Al. So molecular formula of the compound is AlCl3. So valency of that element will be 3. Electronic configuration 2, 8, 3. So therefore number of valence electrons will be 3. So this is all about the number of valence electrons and their respective valency. Okay, and if these number of valence electrons are greater than or equal to 4 children, then we have to subtract these valence electrons from the number 8. Written identified valency from its molecular formula. But when the number of valence electrons in an element X is 4 or less than 4, does X match with the valency of that element? So when the number of valence electrons in an element X is 4 or less than 4, then it matches with the valency of that element. Now when the number of valence electrons in an element X is 4 or more than 4, does 8 minus 6 match with the valency of that element? How many electrons are used to complete the octet? So when the number of valence electrons in an element X is 4 or more than 4, then 8 minus X matches with the valency of that element. So 8 minus X electrons are used to complete the octet. Learn that there is a general relationship between valency of an element and its electronic configuration. So we have to always remember, children, that is valency of an element is the same as the number of its valence electrons if this number is 4 or less than 4. On the other hand, when an element has 4 or more valence electrons, the number of electrons by which the octet is short of completion is the valency of that element. In power, what is meant by atomic number Z of an element? So the number of electrons or protons in an atom is called the atomic number and it is denoted by Z. So atomic numbers, that is Z of some elements, are given here. So write down the number of electron present in the outermost shell of each of them. So element is H, carbon, sodium, chlorine and nitrogen. So atomic number of hydrogen will be 1, atomic number of carbon will be 6, atomic number of sodium will be 11, atomic number of chlorine is 17 and nitrogen is 7. So we have to find out number of electrons in the outermost shell. So hydrogen has atomic number 1. So obviously 1 electron will be there in the outermost shell of hydrogen. Then carbon has atomic number 6. So due to that, in the outermost shell it will be 4 electrons. Then in the sodium, atomic number is 11. So 281 will be the electronic configuration, and according to that, number of electrons in the outermost shell will be 1. Now next is chlorine. It has atomic number 17. So due to that, its electronic configuration will be 287. So obviously in the outermost shell there are 7 electrons in chlorine. The next is nitrogen. So in the nitrogen there is 7 atomic number, and due to that 2, 5 will be the electronic configuration for nitrogen, and due to that 5 electrons will be there in the outermost shell of nitrogen. The number of electrons of some elements is given here. So by using it, write the electronic configuration, the number of valence electron and valency of the respective elements. So elements are given, that is lithium, carbon, magnesium and oxygen. Number of electrons, that is 3. Number of electrons in carbon 6. Number of electrons in magnesium 12 and number of electrons in oxygen 8. Now number of electrons in lithium are 3. So due to that electronic configuration will be 2, 1. So number of valence electrons in lithium 1 and its valency will be 1 only. Now next is carbon. So carbon has number of electrons 6. So its electronic configuration will be 2, 4. So number of valence electrons will be 4 and valency will be 4 for this carbon. Now next element is magnesium. So number of electrons will be 12. Electronic configuration 282. Number of valence electrons are 2. Then valency will be 2 for magnesium. The next is oxygen. So number of electrons in oxygen 8. Its electronic configuration will be 2, 6. So number of valence electrons will be 6 and its valency will be 2, because for completion of octet, this oxygen wants 2 electrons more, and due to that, according to the rule, that is for completion of octet for this oxygen it needs 2 electrons, and due to that its valency will come 2 electrons only. Okay. Next question. Why are the atomic numbers and atomic mass numbers always in whole numbers? So the total number of protons and neutrons in the nucleus of the atom is called atomic mass number, that is capital A. So the number of electrons and protons in an atom is called atomic number, that is capital Z. Now both these protons and neutrons are whole numbers, and therefore atomic numbers and atomic mass numbers are always in whole number. Now fifth question. Sulfur contains 16 proton and 16 neutrons. So what would be its atomic number and mass number? So the atomic number of sulfur is 16 and the atomic mass number will be 32, because atomic number is nothing but number of protons. Okay, and this atomic mass number is always double that of atomic number, and due to that atomic mass number of this sulfur will be 32. Next important topic is isotopes. The atomic number is a fundamental property of an element and its chemical identity. Some elements in nature have atoms with same atomic number but different mass number. So such atom of the same element having different mass number are called as isotopes. For example, carbon has 3 isotopes, that is carbon 12, carbon 13, carbon 14. So the mass number of isotopes is also represented by another method, that is carbon 12, carbon 13 and carbon 14. So the isotopes have same proton number but different neutron number. Now isotopes, their mass number and proton number, and how to calculate their neutron number. Let us see, children. So isotopes are there of carbon, that is carbon 12. So mass number of carbon will be 12, proton number that is 6 only, that is proton number is nothing but their atomic number. Then according to that we can calculate neutron number. So neutron number formula will be A minus Z. Okay, so number of neutrons in carbon 12 will be 6. Now isotope is carbon 13. So mass number will be 13, proton number 6, that is atomic number only. The neutron number we can calculate with the help of formula, that is 13 minus 6, so it will be 7. The next is carbon 14 isotope. Mass number is, that is 14. Okay. Then proton number according to that atomic number only, because atomic number of carbon is 6. Now neutron number we can calculate, that is A minus Z. So according to that we will get neutron number as 8. Okay. So though atomic number is same, but that neutron number can change for these isotopes because their mass number changes. Now hydrogen has 3 isotopes. So they have separate names, that is hydrogen, deuterium and tritium. So find out their mass numbers. So hydrogen has no neutron, deuterium has 1 neutron, tritium has 2 neutrons. So the isotopes of hydrogen have respectively mass number 1, 2 and 3. So therefore nuclear symbols will be 1H, 2H and 3H. Now let us complete the following table. Isotopes of hydrogen and chlorine are given. So we have to write down their respective proton numbers and neutron numbers. So here first isotope of hydrogen, that is 1H1. So proton number is 1. So obviously neutron number will be 0. Because here mass number and proton number that are coming same. So obviously after subtraction neutron number will be 0. Now here isotope is second, that is 2H1, that is deuterium. Proton number is 1 and neutron number will also come 1 because 2 minus 1. Now here isotope is, that is tritium, 3H1. So proton number is 1 and neutron number will be 2. Now next isotope is chlorine. So chlorine, that is 1735. So proton number is 17. Then neutron number we have to subtract 35 minus 17. So that will be 18. Now next is here, next isotope of chlorine, that is chlorine 37. That is chlorine 37, 17. So proton number is 17 only. Neutron number will be 37 minus 17. So it will be 20 is the neutron number. Uses of these isotopes. Isotopes of some elements are radioactive. They are used in various fields such as industry, agriculture, medicine and research field also. Now uranium-235 is used for nuclear fission and production of electricity also. Some radioisotopes, that is cobalt-60, are used in medical treatment of fatal diseases, that is causing death diseases like cancer. Now iodine-131 is used in the treatment of goiter, disease of thyroid gland also. Okay, that is the disease for thyroid gland, and for that treatment of this goiter we can use iodine-131. Now the radioactive isotopes are used for detection of cracks, that is leakage in the underground pipes. For example, sodium-24. Now radioactive isotopes are used for food preservation from microbes also. Okay. Then the radioactive isotope carbon-14 is used for determining the age of archaeological objects, that is ancient objects. For determining the age of that ancient object, we can use this radioactive isotope, that is carbon-14. Nuclear reactor. So nuclear reactor is a machine that generates electricity on large scale by using atomic energy. Okay, so you can see this atomic energy in case of figure 5.10. Now in a nuclear reactor, the nuclear energy in atom is released by bringing about nuclear reactions on a nuclear fuel. Okay, so on nuclear reactions, for bringing the nuclear reactions on this nuclear fuel, we can use this nuclear energy. A nuclear reaction with example of nuclear fuel, that is uranium-235. So on bombardment with slow speed of neutrons, the nucleus of the isotope uranium-235 undergoes nuclear fission. to form nuclei of two different elements, krypton 92 and barium 141, and 2 to 3 neutrons. So on decreasing the speed, these neutrons bring about fission of more uranium 235 nuclei. So in this way, a chain reaction of nuclear fission takes place. Okay. So there is a nuclear fission chain reaction. You can see in this picture, children. You will understand that there is a nuclear fission of this uranium 235, and due to that there is a formation of different elements, that is krypton 92, then barium 141, and 2 to 3 neutrons also. Now there is a large amount of nuclear energy is released during this chain reaction of fission. Fission means what? Breaking. So this chain reaction is kept under control to prevent the probable explosion. Okay, and to control this chain reaction in the nuclear reactor, it is necessary to decrease the speed and number of neutrons. So for this purpose, following provision is made in the nuclear reactor. Reactor we can use moderator and controller. So moderator is what? Graphite or heavy water is used as a moderator for reducing the speed of neutrons. Then controller. To reduce the number of neutron by absorbing them, rods of boron, cadmium, beryllium, etc. they are used as a controller. Now the heat produced in the fission process is taken out by using water as a coolant. So water is transformed into steam, and by means of this steam, turbines are driven, and therefore the electricity is generated in this reactor, and due to that we can use this as a controller. Now in India, total 22 nuclear reactors in 8 places are functioning. Apsara at Bhabha Atomic Research Center in Mumbai is the first nuclear reactor in India, which went critical on 4th August 1956. So India has large reserves of element thorium 232. Therefore, Indian scientists have developed a future plan for nuclear reactors based on production of the isotope 3 from thorium 232. And for watching the video and for your attention.